So what about the question is causing the first problem?
The biology.
The biology term.
I'm confused as to why.
So the half-life of carbon, now it tells you over the side here, look. The half-life of a radioactive material is the time taken for the number of nuclei to half. That's what I was talking about yesterday. So a sample of carbon 11, it's just the name of whatever the material is, has 10,000 nuclei. Right. Make a table of values for 5 20-minute intervals and write down a function for the number of nuclei after X number of 20-minute intervals.
I'm not confused anymore. I just didn't read the green box.
So, table of values is going to look like a table of values, right? So what's in my table?
Time.
Okay, so I'm going, I don't know why I did it this way, it doesn't matter, but yeah, all right, after time. Okay, time in blocks of
20 intervals, minutes.
20 minutes. Okay, and what will the other thing be? The number of nuclei. So, it says, has 10,000 nuclei. That's after how much time?
20 minutes.
No.
Zero.
Zero.
Oh, yes. I do have that written down.
10,000. Okay. Then after one block
5,000.
of 20 minutes, it's 5,000. Yeah. After 2 blocks, this is what it's saying. Make a table of values for 5 20-minute intervals. Write down a function for the number of you after X number of 20-minute intervals. Okay? So this is why I'm doing it as the number of intervals rather than the amount of time itself. Okay? So 2 lots of 20 minutes. So that will be at 2,500. 3 will be 1,250. 4 will be
625.
625. And it says a sample of carbon make table values for 5 20-minute intervals. Is that enough? Or do we need more? 1, 2, 3, 4, 5. So what's that going to be?
312.
So what's happening every time, by the way? Multiplying by
1/2.
Halving by 2.
halving by 2. Well, technically, I guess. Find the number of nuclei after 3 hours. That's 20 minutes, 40 minutes, 1 hour. So we need 6, then 7, then 8. That's the 9th one, yeah? Will that be 3 hours?
Should we just do it or should we?
Well, that's up to you, right? What should we do?
Make
A general
a
formula?
thing.
We could try and do a formula, couldn't we? Is it basically just another geometric sequence?
Yeah.
Right? So do we not have un equals u1 times r to the power of n minus 1? Does that work? The n minus 1 bit this time.
Yes.
Okay, well this one's x, alright, so do we need x minus 1?
No, because x is x equals n. Wait,
No, because n is the term number, x is
Yeah.
the time.
Okay, so what's different about this one, this situation, our actual context and the sequence stuff that we've done in the past?
Time isn't 1, it's 20.
Okay, not that actually, time is 1, it's a block of 20, as long as we fit that at the beginning. The main difference is the first term is actually 0 time. So if I were to put this in, so U1 is what? Which one?
The second one.
No,
10,000.
it's the
Oh, it is.
10,000.
Oh, yeah.
But the time period is 0. So this is the main difference between a geometric sequence and an exponential function.
Oh, yeah, 'cause it starts on.
And that's why when we have our geometric function, we don't use this straight out. We actually now have f of x equals k a to the power of x, yeah? Same principle, but the difference is because we start at 0, so u1 is 0 in this case. u2 is 1, so that's why we don't have the n minus 1 bit anymore. Does that make sense? That's quite an important thing, especially if we're going to do like the financial stuff that's coming up. Alright? So what do we do then? So then the number of nuclei is what we want f of x. K is the
As intersect.
that's the initial value, isn't it? That was the intercept, like we said, yeah? Where we start from. Yeah? So that'll be the 10,000. Which makes sense, doesn't it? Because 10,000 is the U1. There's no difference there. Yeah? Multiplied by, what's A? The ratio, which is a half. I'll put it in brackets. And then to the power of x this time. And we should just do a little check, because if it's x or x minus 1, well, if x is 0, that's when we start, yeah? And then we should have 10,000 times a half to the power, so let me just write that down. I'm going to check. So I want when n is 10,000, okay, I know that x is 0, yeah? This one. So I'm just checking that I get that. So let's do n equals 10,000 multiplied by a half to the power of 0. And what do I get? N is 10,000 multiplied by 1. So n is 10,000. Now, of course, you don't need to do that every time. Maybe just a mental check that I've got the right thing, or, you know. But I've just checked that I get the right thing. So that is my exponential function. So I guess the big thing there is to highlight the fact that it's x and not n minus 1. It's not x minus 1 because we're starting the 0. The initial value is not the first, well, it is the first term, but we don't call it 1, we call it 0. So that's the big difference. All right. Everything else is the same. All right, we haven't solved our question yet, though. The question actually is, find the number of nuclei after 3 hours. So what do we do?
That would be the number.
So after 3 hours, okay. Is there any way, like if I said find it after 500 hours, what would you do? It's not the limit.
1,501.
Well, 3 hours is when x equals 9. So what do we do? Times 3, isn't it? So whatever the number of hours, why is it times 3 in this case? Because 3 lots of 20 minutes. So that would be a way to figure out what it is in this kind of situation. There are 3 lots of 20 minutes, so I know x is equal to 9. So I chuck that in, so the number of nuclei is 10,000 multiplied by a half to the power of 9. What do you get? Say again? What would you give as your final answer?
19.53. It doesn't. Nuclear. 19.53. 125.
What did it ask you? Did it ask you to do anything in the question? Doesn't say round it or anything.
No.
How many nuclei is it possible to have?
No.
So it wants us to go down.
Oh. You can only have a whole. Well, they're objects.
So it has to go down.
So you can have half a nuclei. That's not true.
But it's already left above.
19.
Well, it's the number of nuclei. Now, I will defer to your physics teacher. You can go and ask your physics teacher what they would say. I would suggest it's something to think about, though. Probably in this level. It'd be interesting what it says in the back of the book, actually. Have a look. Why don't you check it out? Because the number of nuclei.
20. Well, should I have very fast? I had it once.
So n equals 20. Why is it 20?
Because they rounded up. But why
Why
would
do they round it up? Yeah. Okay, so if you think about it, if this is a nucleus, basically saying we've got 20 of them, and after 3 hours, one of them has degraded so that there is only half of one left, basically, yeah, 19.5. But that doesn't actually happen, does it? There is still 20 until the whole thing is gone. So this is where your rounding needs to be thought about in terms of real context. How many nuclei have I got if it was 19.001? 20 still. The 20th one has not disappeared yet.
Because it's still part of it is still there.
Yeah, right? Because it doesn't degrade, it doesn't have little bits fall off every time, right? It is still there until it's not there. So if there's any part above 19, when it's like, how many buses do I need to take 28 people, yeah? If 20 people fit on a bus. Just because there's 8 people left, you don't go, oh, you only need less than half a bus. No, it don't work like that, yeah? And you can't leave the 8 people behind. And you don't put them on a roof, right? You need a second bus. It's the same kind of thing. Even if I've only got 0.001 of a nuclei left, I would still have 20 nuclei. So this is where your rounding rules are not applicable. All right, it's about context. How do you feel about that question now? Would it have been more efficient or effective just to go down the list and get to 9? Yeah, probably. Could have just got to that number relatively easily.
Now we know the
Apart from, it now says determine how long it takes for the number of nuclei to reduce to less than 10% of the original number. Determine how long it takes for the number of nuclei to reduce to less than 10% of the original number. Okay, so less than 10%. Now this is where the formula now comes into play, doesn't it? So we're glad we did it, because we were going to have to do it anyway. So what is 10% of 10,000? 1,000. 1,000.
So you don't really need the formula. Because
You could just keep going.
So now it's 4.
Well, we already wrote them below 1,000.
Yeah. It's not 4, it's an hour and 20 minutes. Yeah. 1,000.
But we've only got blocks of 20 minutes.
We're trying to find the exact time.
Yes. So would it be 84 minutes or 83 minutes or 82? Yeah? 81.5 minutes. Because you notice what we've been asked to do is simply it goes down in half. But there is a time when there was 9,463, right? Where is the level I'm looking for? Somewhere in here, yeah? Between 1 hour and 1 hour 20 minutes. So because we've only done it in blocks, we can't just half it. What do you do to find the bits in between? Do you half it? Right, so we need a different method. So what we do is, this is where we do need our formula. So we need to say where 10,000 multiplied by a half to the power of x is less than 1,000. Using our inequalities. But you're alright with inequalities because we don't have to do anything special with inequalities, do we? Apart from make sure our final answer is. Okay, so what do we do?
Well, you could divide both sides by 1,000.
Not 1,000. Divide by 10,000. So half to the power of x needs to be less than 1,000 divided by 10,000, which means a half to the power of x needs to be less than 0.1. Make sense? Now, we've come across this before with our geometric sequences. We're doing exactly the same thing again. How do we do it? Could be, yeah. But we don't have our the right calculators for it. So, without having log to the base of half, then what's our method? Trial and error, no? So we just give it a go. What's a half to the power of 1? 0.5. Yeah? Put it in this. Half to the power of 2. Half to the power of 3. Half to the power of 4.
1.060. Yeah.
What's that? That's really unhelpful.
But now we can go in between.
You get to 0 point.
So now we want to say where x is between 3 and 4. We could have said that anyway, right? Right?
That's the exact same result.
Exactly we had before, yeah, exactly. But we can say when x is 3.1, x is 3.2, we can do our trial. Now, if we were going to do it using logarithms, what would we do? Anyone remember? If I wanted to do this, I'd actually say log to the base half of 0.1 equals x, yeah? Are you happy with that? So if we've got a calculator that we're able to do it with, well, for me, I can do I've got a log base, but on my calculator, you can't do it. So log base 0.5 of 0.1, and I get the answer 3.321. So what would you do? Well, you would be going through the process, if you're doing trial and error, of trying these values, and you would get to 3.3 and 3.4. Yeah? So you wouldn't have to go too far. And then you would start in between, right? 3.31, 3.32, 3.33, and you would just put it into your calculator half, and you would end up probably getting as far as this one and going, that's enough. Yeah? What does that mean? Well, I've got x is 3.31, so the question is, how long?
3.3.
Which is? 66.42 minutes.
I think 3.32 might just be over.
Well, actually, that is equal to 0.1, so we wanted less. So we want at 66.42, so we probably want to be above that, don't we? But at 66 minutes, 66 and a half minutes, yeah? So we might actually say we round it to 67 minutes, yeah? We could answer that. Does your Desmos calculator that you have on your e-assessment have the logarithm thing?
Yeah.
Why are we multiplying by 20?
Because x is the amount of 20 minutes.
Oh.
Yeah? Alright, let me have a quick look.
How do they not have it in its
Yeah, they only give you log to the base 10, as far as I can see, or log to the base e, natural logarithm. Yeah, the trial and error bit, is that you just have to fill out, write a few down. All right, what about the next question then? Because these were the important ones that I want you to be able to do. Yeah, that was just one question. There's a reason I wanted you to do all these ones. Why do you think I wanted you to do this one? This one. The previous one was just that's the structure of a question. There was nothing particularly hard about it. It was in context. It was to do with the half-life thing that I talked about yesterday. But this one has a specific thing that does catch people out. No. The thing in it, all right, is what is the ratio? Yeah, so we're decreasing by 22%. So that's the question for me. Do you know, and you should do, but I'm just checking, how do we decrease by 22%? How do you do it? Because we got, with our half-life, we were told to just half it every time. So we divide it by 2, or half it by 2. You know?
Multiplied by 22 over 100.
Okay, we don't.
11 over 50.
Close though. So that's the same thing. Well, why would you say it? Multiplying by 22 over 100 or multiplying by 0.22 is close, but no carrot. Because what do you do when you multiply by 22? You find 22%, yeah. I don't want to find 22%, I want to decrease by 22%. So what do I multiply by? Right idea, but no, it doesn't. Think about it, what you just said. Find 22% leaves me with what? No.
I don't know.
Oh, you divide.
No. If I find 22% of something,
78%.
how much do I end up with if I find 22%? I get ended up with 22%.
Yeah.
If I want to decrease an amount by 22%, I need to find 78%. Okay, so to decrease by 22 is the same thing as find 78%. Okay, so you multiply by 0.78. Okay, So not that, right? Because that finds 22%. We actually want to model, and that is our ratio. Okay. So the reason why write a function to model future DVD sales. Okay. So in 2010 they sold 470. So is that the initial value?
Yeah.
Okay. So sales is equal to the initial value is 470. You multiply that by 0.78 to the power of
What's sold? No, this is sales.
okay. X is the
Years.
number of years. Yeah. Okay. X is the number of years. Right. Use your function. So that's it, right? Why do we never have a plus C on these questions?
Because you already.
Because 470 is new stuff. You already have it.
Yeah.
But what does plus
Oh,
C
that takes
tell
the
you?
entire
Usually-
function.
Well, it
It's just
the
adding.
initial thing.
You,
but this is the
because you
initial.
always start at having sold 0, you don't start at
No.
having sold
What does the
5.
plus C tell you in the function? We talked about this yesterday. What do all exponential functions have as a property? They have an asymptote. Where is the asymptote? On the x-axis, which means when y is 0, yeah? Yeah? If I add C, it shifts up or drops the asymptote. But if I add an asymptote that's not 0 in this case, what am I saying? Sales will never be 0. Right? That's what it is in this case. Sales will never actually reach 0, which in reality, once it's reached 1 and it gets less than 1, we can say we're done, right? That's the limitation of the function. If I add 100 to it, for instance, I would be saying sales will never reach less than 100, which is not feasible. In reality, things will get to 0. So what do we have to do then? It says use your function to estimate the number of DVD sales players the store will sell in 2018.
65.
Okay. So how many years have gone by? 8. Okay. So we're saying x is 8. So we've got 470 multiplied by 0.8 to the power of 8 gives you
65.
that exactly.
No, 64 point something. 64.3953752. And you can't have a half of something.
Have I sold 65 or have I sold 64?
Or 64.
Think about it in context. If I haven't sold 65, I haven't got the money for 65. So 64 would be a more reasonable thing, yeah? Okay, that one's simple easy, right? The only reason I gave you that question is this bit.
The book
Yeah.
put it in a decimal, but that's a lot.
It you can actually in business and finance you do decimals because it makes you sound a bit better, yeah. You notice what I have told you to do this, and I always do it, which is write your unrounded answer before you round. Don't round it, because if, for instance, they wanted an answer of 65 and you wrote 64, there's a reason to say you're wrong. But if you wrote 64.39 and they agree with that bit, and then you round, they'll give you the marks. So, like, you've made a decision, it's a perfectly reasonable decision. But if you do it without the unrounded bit, that gives there's just a little bit of doubt. All right? Okay, easy question. It was just the percentage bit that I wanted to make you think about that. All right. I think you'll be able to do Question 5 then, it's the same thing, the 12% per week. Go for it, you can do that.